All right, I'd like to welcome everybody to this October meeting of the Delaware Astronomical Society. First item, do we have any new members like to introduce yourselves? I'll turn this around. There you go. Tell us who you are.
I'm Kevin Malone, a sophomore at uni and a physics major.
Welcome.
Nice.
Wonderful. Welcome. All right, do we have anybody else?
New members or guests?
Any others? All right, very good. All right, so let's get started. First item, dues reminder, Bob.
I just wanted to say we started the dues collection process. You know, basically we sort of run on an annual basis. So we start collecting around November 1st for dues. The dues remain $30. So all current members should have gotten an email from me, which gives us a whole number of different options of how to pay. You can pay at any one of these types of meetings or any of the workshops. You can pay any board member. You can mail a check to me, or there's a number of PayPal options in the email, or it's all also in the focus. The last page of the focus will tell you how all that thing stuff. So you know, we're just going to collect dues until most people sign up. So the sooner you sign up, the less reminders you get from me. Send it out plus. I do have one. I will show everybody how this works.
What? Dramatic. All done.
That easy.
That easy.
And actually, I'm going to give a little plug as a former treasurer or former dues renewal haranguer.
Right.
Make it easy. I got the email. I probably was the first one to renew. I clicked a button. I think it was about 18 seconds later, I was done. Make it easier on yourself. Make it easier on Bob. Find the email. It's got a PayPal link. Just click it. And in about 30 seconds, you'll be done. Don't procrastinate like, oh, I'll do it, because you won't. Just do it. Make his life easy. Having done it before, it's annoying that in January you're sending the 14th reminder to pester people to renew. Make it easy on him. Bob's doing an awesome job
Yes, thank you, Bob.
keeping up our treasury. Let's make the
Great
job
job.
as easy as could be.
Great job, Bob. All right, so next item, intro to astronomy course.
Yeah.
Tell us about that. Yeah, it's like sometimes focus. Oh, there it goes.
Hi, I'm Jim Kirshen. I'm the outreach education chair here for the DAS. And we're putting together an intro to astronomy course that is going to entail 4 sessions. And it's going to start November 7th. It's going to be on every Tuesday of that month, except the last one, I guess. The one that entails Thanksgiving week. We're going to skip that week and end up in December. So it's going to be, I'm going to send out an email to all DAS members and others for a sign up. And the sign up is going to be capped at 25 members. So sign up as quick as you see it, because I think it'll be going fast.
There we go.
So anyway,
Did we mention the cost?
it is $30. The cost is $30, and basically what that entails is that gets you a membership into the Delaware Astronomical Society for a year.
Or I think the other way is active current members, there is no charge.
That's right.
Yeah. So,
Very nice, perfect.
Jim, thank you for resurrecting the intro to class. That's been a great thing that we've done, but it's been a while since we've done one, so it's awesome that we're resurrecting that.
Yes,
It's a great service to our members.
Yeah,
Yeah,
It's all good, Bill.
great service.
it was 2014. I
Yeah.
think it was. Yeah.
And yeah, you are standing on a legacy, so thank everyone that. I think that's awesome. I mean, and it's 100% aligned with our mission, so it's great that we're doing it.
All right, next item is the AP6.
Okay, so the next astrophotography special interest group meeting is October 21st. That's Saturday, 7:30 p.m. And we're doing it on Zoom because it's gonna be rainy anyway. And So the announcement's already gone out on groups.io. If you're a member, if you're subscribed to groups.io, you should get that. If not, you should get on groups.io for the DAS. Lots of announcements go out that way. No special topic at the moment, but it looks like we're gonna have some videos of the annular solar eclipse. And a little bit of information on how to make a video out of multiple images.
Even when it's raining?
That takes expertise.
Awesome, thank you. Actually, great segue. And so, are you aware of our groups.io? Okay, as a new member, it's really probably after joining the club, the second most important thing to do. It's an email service that we use to stay in touch with each other, basically in between meetings. It's very simple. If you go to the website, you just click a button and you're on the list group. You will receive emails about things that are happening within the club, but you as well could send emails like, hey, I'm trying to figure out how to do X, who can help me? Or a lot of times people are buying and selling stuff through there. So it's really after joining the club, the second most important thing to stay connected with the club's activities. And if you have any questions about it, we can help you after the meeting.
And just remember that message goes out to everybody in the club, basically. Just keep that in mind. All right. Yeah. So next item. All right. Next item, we have the Woodside event.
Yeah. So this Friday will be the next Woodside Creamery outreach event that I get to cancel.
Yeah. Yeah.
This is, I was just chatting with Dave. Dave, I've been involved with Woodside events for a good long time, and Dave's been doing them longer than I have. And pardon the rant or moan or whatever you want to call this. This has been the worst season of outreach that I can ever remember. I believe this is our final event at outreach. Oh, sorry. Our final event at Woodside. And if it rains as it's predicted to, that will mean I think we're 1 for 6 for this year. I remember most years, if we're unlucky, one event would get rained or clouded out. This year has just been uncanny. So keep an eye on your emails to see the announcement where I will be canceling this event. So stay tuned. See, that's why you need to get on groups.io to find out that we're canceling an event this Friday. In the off chance that the weather prediction improves, my general take, if it's raining, I'm not going to be there. If it's cloudy, I might show up just because I'll get an ice cream.
Yeah.
And if the clouds happen to part, I'll pull out a telescope. But obviously, it's up to everyone's individual discretion if I even go at all if they want to come out. And again, pardon the bemoaning. I've never seen a word. I mean, in general, I think all of us astronomers have realized the past 6 to 8 months have been pretty dreadful.
Very rainy and smoky.
Smoke or fire.
Yeah.
So,
Right.
is there another outreach event, Jim?
Let's see.
I think so.
You can pull up the calendar.
Yeah, let's do that.
And is that sharing, Rob?
Not right now, but I can do that.
Okay. And I do have the calendar brought up, so it's already open.
Should be over in one of these windows. Hold on.
It's a Firefox. There it
This
is.
one.
Which one?
So maybe not on the calendar?
I'm probably not on the calendar. We canceled that one event that we were gonna have at the Newark Reservoir.
Okay.
Oh, okay.
We did cancel that. I've gotten a number of requests for events from other people. I got one recently from the resident naturalist at Lum's Pond.
Cool.
Nice.
So she hasn't gotten back to me yet as far as scheduling, but I told her basically what we were looking for a venue, and so she'll let me know.
All right. Sorry, I thought you did have one on this list. Okay.
No, I do not.
All right, Mary, do you have anything about the book club?
This is Robert Stack. I'm going to be leading the next book club meeting. It's October 26th, and our book is going to be Eye of the Beholder. I guess you can almost see this if it doesn't blur it out. It's about Johannes van Meer and Anton Leeuwenhoek. It's all about painting, perspective, and early optics. Leeuwenhoek was a early user of the microscope, and it's very detailed, and it really goes into a lot of astronomy. There's a lot of astronomers in here in early optics, a lot about the telescope, a lot about the microscope. So it's a very fascinating book.
Author will be with us.
So
And the
is
author,
calendar,
Laura J.
oops,
The author, Laura J. Snyder, will be with us discussing her book.
so is the calendar inaccurate then, Robert? Because it shows that Jim
Let me
Shaq
see.
was awesome to point out that the October and November book club calendar showed the same book. And the October one does not show what you just described. So you might want to take a peek at that.
On the web page at DAS, October 26th is this book, Eye of the Beholder.
So I'm seeing the book nobody read, Chasing the Revolutions of Nicholas Copernicus for October
That's
26th.
November.
That's November.
Right, but it shows up
Oh.
under October on the calendar.
Might want to
Okay,
check
we'll have to check the calendar. On the web page at DAS, it's November.
Gotcha.
So we'll have to check the calendar.
Yeah, just
There's a second.
double check the calendar if you don't mind.
Okay.
All right.
Cool.
Anything else to say about it, or is that it? Okay.
That's it.
Okay, great. Did we have any other announcements that I missed? All right, then we can get started with the next part of the meeting.
Great.
Uh,
Actually, you can stay right where you are.
oh, I can just do my presentation.
So,
That's smart. Yeah. It's not-
Last month we did, gosh, that was last month, felt like a year ago. We did what I did over the summer. We had a lot of amazing and awesome talks. And Rob actually had a little mini talk that he wanted to present that we just ran out of time for. So he's going to take a few minutes and share about a cool thing he did with the Starlink satellites. And then from there, we'll move on to our main topic.
Let me hide that, actually. All right, so really quickly, I just want to point out that a few weeks ago, Bob Shuttlecock shared something really interesting with us. He shared with us that there were a bunch of Starlink satellites that were going to go overhead. It was going to be really dramatic. And I'd heard from a number of members that they'd seen this out in the field, usually by surprise. They're like, whoa, what is that? And so I was like, hey, that's cool. I would like to see that. So he had found this site that had these predictions. And we all went up on the roof. We were all excited and we didn't see anything. But I will say that I tried his app again later. I went out with my wife on one evening. I brought my camera out and it was spectacular. So it definitely is worth checking out. So I'm going to talk a little bit about that. The website or the app is called Find Starlink. So this website, I can certainly send it to everybody so that you have access to that. There's also an app for iPhones and Android phones that has basically the same name, Find Starlink. And you put in your location, and then it brings up all this information about the upcoming predicted timings. It gives you the area of the sky to look at, tells you how high it's going to be, where it's going to go from and to. So
Rob, this is just for trains, not individual ones.
So yes,
Okay.
the whole point of this is to look for those trains of Starlink satellites. And you can even see in the background here, an image showing that on their website.
Rob, do you know offhand, I have a book actually, and so you mentioned this, if Heavens Above does trains.
I don't know that, but it'd be cool if they do. Yeah.
The trains, okay, cool. Okay.
So here's another page on that site. This basically shows the Starlink satellite trains and where they currently are, because at this point they're kind of going together for a while after they launch, and then they kind of spread out and go off in their different areas of the sky. But for now, they're kind of grouped together as a unit. And so it kind of tracks those. And this is what it uses to make its predictions, as I understand. So you can definitely see where the satellite trains are at this time on the site, as well as the timings that I mentioned before. So this was my first attempt at a photo. I actually did several because I was out there, I was ready for it. but then there was a tree in the way, and I'm like, wait a minute, let me go up and look over. Oh my goodness, there they are. So I had to grab my tripod, run up to the front of the driveway, slap it down again, and it wasn't quite stable yet. But I did get a couple shots out, and it was pretty spectacular. As you can see, there's a number of individual satellites in the train. I believe it's 21 per launch. And they're not all exactly the same, and gradually they will spread out. See, they're slightly off from each other, but they're pretty close to in a line. Counting them, I think it's close to 21. Yeah, I think a couple might be right over top of each other too. So I got a couple pictures of that. I told my sister about it. I gave her a call and said, you should check this out. They were actually driving home from something out in Western Maryland where they live. I think it was a game that they were at. And they looked out of the car and they're like, oh my God. It was really spectacular. And later, a couple days later, she used the same link that I sent to her, and she got these photos with her iPhone. She just picked it up, took a photo of it. Because she was really excited about it and wanted to see it. Because actually everybody else in this car got to see it except her because she was driving. So she wanted to see it again because she heard about it from them. And so she used the app. They predicted another sighting and they took photos. And that's it. You guys can check it out. It's definitely worth seeing. Again, it's Find Starlink. You can just type that into Google. And there's an app for the iPhone, app for the Android, and a website. You can use any of the above.
I would get a coincidental sighting at one of our
Oh, yeah.
star parties out here.
That was the other night. Yeah, that was pretty
Last
cool.
week.
Yeah.
And I would encourage, I mean, we obviously can all download the app and keep an eye on it, but if anyone happens to catch that there's a Starlink train or deployment in this area, shoot a note to the groups.io. There could be a number of members that might not have the app or might not be watching it. Seems like it could be a great thing to let the broad membership, and give them whatever details, start time and rough spot in the sky. I've seen now 2, and they were very, very different and both really, really cool. And I'm going to try to make an effort to see more of them. So thank you for sharing that, Rob.
Yep. Check it out. We're seeing.
All right. That leads us to our main topic for tonight. We are rejoined by our NASA ambassador, John Conrad, actually rejoining us for the first time in a couple of years in person. We've had a couple of talks with John since the pandemic over Zoom, but it's great to have him back and great to have him back here in person. I will claim 100% complete serendipity. This might be one of the most accidentally perfectly timed talks that has ever been scheduled. I think, John, we probably scheduled this 8 months ago, at least without me realizing how timely it was. John is going to be talking to us today about the OSIRIS-Rex mission, which, without stealing all of the surprise, was a spacecraft that went out to an asteroid, gathered some bits of it, and returned those bits to the Earth. And the timeliness was like a week ago, it actually landed on Earth safely and properly and gave us some asteroid samples that we can study. So again, I did not realize that the timing was going to be as such, but it's awesome that a week after OSIRIS-Rex came back and brought the samples to us, we have John to tell us all of the awesome details about that mission. And with that, I welcome back John Conrad. And I can't see, so let me. And actually, Rob, do you want to help me set this up with the? I always tend to screw it up. We will, I guess, pin this one, right?
Yeah.
And then
I
go
know
to
we
this.
clicked that. Yep.
And then just launch it, right?
Yep. And that should be good.
And then we'll
You
just
did
get the
fine.
camera aimed up.
It was perfect.
After 4 years, I finally am figuring it out. John, all yours, sir.
Okay, let me get this. I hate to have this thing in the way, so.
Oh yeah, do what you need.
yeah,
Do you want to just get rid of it completely?
I'll just, let's, where'd that go there? No. I haven't used a mouse, but maybe once in 30 years.
Gotcha.
And let's see, I can take. Anyway, that's.
I get you. There, let me help out.
That's.
And do we probably advanced a bit more than you were? There we go.
There we go, right there. So I've started with a technical problem. I don't know about anybody else, but I can't get good reception to see what happened after the first pitch. Nobody,
Either-
I mean, I half expected the group to be looking at their laps for most of the things. Feel free.
Sheila made me put it away. I'm
Does
sorry.
this turn off close to light?
Do what you please.
That's a little better. So it's great to be back. The January 2020, which if you know about COVID, isn't quite the right month, but it was the month when I broke this ankle. So I was locked down, and a month later, I got really locked down by COVID. And so 2020 was a bad year. At any rate, I'm back and finally have the mask off, and from what I've read lately, I don't think the latest strain has taken down too many people yet. So we can hope that this particular cold season is not going to be bad again. At any rate, I'm just delighted to be here. You're looking at a wonderful asteroid Bennu. You're looking at a Lockheed Martin spacecraft there, OSIRIS-Rex. Both those names, Osiris and Bennu, are from Egyptian mythology. So these things don't happen by accident. At any rate, I like to give credit where it's due. Let's start with the fact that Jason Dworkin, who, if you guys have paid attention after the landing or during the landing, which was covered for hours by NASA on NASA TV, which is easy to find. You just put NASA TV into your browser and there it is. Jason was actually one of the ones that they interviewed during the many hours of coverage they had. A really good guy. And once in a while, I give a lot of credit to somebody that's helped us to understand. He provided maybe half the slides that you're going to see and was just very, very instrumental in helping me with this presentation. Down in the lower left there, you can see a lot of credits. And so on the left, well, you see the NASA ball there, and there are several NASA centers that have been involved in this. You see Lockheed Martin, the spacecraft contractor, and you see the University of Arizona, and I wanted to make sure and give credit to them because they've been involved in extraterrestrial sample return research for decades now, starting way back with the lunar material. So there are a bunch of others I could give credit to, but those are the main ones. So we're going to talk first about that name. And naming your program is one of those rare moments for every project manager or project scientist where he gets to think about, his legacy. And so it gets a lot of thought. And as a matter of fact, a week ago, during one of the press conferences since the return, the guy that actually gave it the name went through this whole thing. But we'd all figured this out previously. It's one of those rare acronyms that really kind of tells you what the mission was all about. O for Origins is the primary purpose of all of these sample return missions. We're trying to get pristine material back from outer space, deep space typically, and get a look without contamination at what it is that the initial material that formed the solar system is like. And then comes SI and RI, and those two sets of words, spectral interpretation and resource identification, say a lot about what the many instruments that are on OSIRIS-Rex actually did with remote sensing while they were out there for more than 2 years, orbiting the space or orbiting the asteroid. So it's not just about sample return, it's about much more than that, as you'll see. The second S is for security. And in this case, we're talking about that wonderful new security we think about called planetary defense, where there's an official planetary defense officer in Washington, and we have a network of these people around the world now worried about near-Earth objects that become potentially hazardous asteroids that might actually hit us at some point. And we're trying to get something, or at least some understanding under our belt before one of them has our name on it so that we can figure out what to do about it. And so we learned a fair amount about one of the effects on orbits called the Yarkovsky effect, and we'll talk about that. And finally, Rex, Regolith Explorer. Regolith is that, 50-cent word, as we used to say, that came about at the time of Apollo. Instead of just saying surface material, we like to say regolith. So that's what that is. So we gathered up some of that and brought it home. This is a cartoon that they gave us that kind of talks you through the fact that even though we've been here and our instrumentation and our exploration techniques have improved for at least the last thousands of years, and the Earth's been around for 4.5 billion years, there's almost nothing that we can go and find near or on the surface that we actually are sure is original solar system material. So we have to get it from somewhere else. And so the problem always is contamination. So we have several levels of trying to get material from outer space. First of all, on the left here, you get the typical kind of meteor hunters. And so they form clubs, and they like to communicate with each other and go out on expeditions. And they've collected up a lot of meteorites, stuff that comes from asteroids and comets that's come to Earth, but they have anything but good, let's say, clean room methods. And so you don't get much out of it except the excitement of it. Next over, that's actually a crew from a university in Africa that do have a clean lab. In fact, their facility, and they've gone out and found an asteroid piece, a meteorite, and they're going to take it back in. And then the best of all that we can do on Earth, you're probably well aware, happens on that vast expanse of millions of square miles that's almost all white in Antarctica. And it has the other benefit, not just that it's white so you can see things that land on the surface, but it doesn't have anybody there. And so when you've located something, there's not going to be, some other guy in a pickup truck that's going to drive out and get there ahead of you. So that's the best we do, and they take them in, and so we have relatively uncontaminated samples that come down in Antarctica. But what we really want to do is what OSIRIS-Rex did, and go out and get something and bring it back under controlled conditions as we've done. And so let's get on that with that. So we're getting at the uncontaminated material. So we've got quite a history of bringing samples back from the solar system. Beginning with Apollo, as you're all aware, 12 people on 6 missions in the late 60s and early 70s, brought back about 900 pounds of the lunar surface and subsurface material. And some of it is still in storage and will be brought out in the future when we have even better techniques and instruments to look at it. But quite a bit of it has been analyzed already. The Soviets also had some successes as opposed to what's happened recently in the 60s and 70s. And so they brought back some samples. The Chinese, their latest mission was, as it says in 2020, the year before that, they made a lot of news by going to the far side of the moon, being the first nation that landed there. But Chang'e 5 actually came to the near side and picked up some material and brought it back. And the next mission that's going to do that, hopefully, will be the manned mission, Artemis. And that's been, we've been getting closer and closer to that. And the latest is probably 2026. There might be a landing in that year, but we'll see. At any rate, there's supposed to be the next launch in 2024, although it's kind of moved to the back of 2024, I think. And that's going to go beyond the moon with people in the Orion capsule, but not land. And so the landing ones are going to come a little later. And the Chinese have an announced moon program to land people on the moon by 2030. So in a sense, we're in a little bit of a space race again with guys around the other side of the world. Next comes a couple things where we sampled the plasma material that is the solar wind and the tail of a comet. And both those, Genesis and Stardust, are Lockheed Martin spacecraft. So they've gotten a lot of experience doing this kind of sample return. As a matter of fact, the Stardust mission, which landed pretty much at the same place that OSIRIS-Rex did, allowed them to use the same SRC, sample return capsule. And so they learned a lot from that, and they repeated the success this time around.
Sensors from the right orientation.
And by you said landing in the same spot, you mean on Earth or?
On Earth.
Okay, yeah.
When they brought the sample back, that was the key there. And legacy design is something that every engineer loves. Nothing like getting the risk out before you use it again. All right, and then finally, the Japanese, JAXA is their NASA. They went to two different asteroids, one stony and one carbonaceous, like Bennu is, and they did it very successfully, as you'll see here in a minute. The collaboration that I mentioned earlier with the University of Arizona is kind of a three-cornered thing. The Japanese, NASA, and Arizona all work together on these things. And then finally, what's coming up at the bottom here, you see two missions to the Mars system. Phobos is the larger moon of Mars, and the Japanese are supposed to have gone there, landed, sampled, and come back within only about 4 years. So we'll see how that goes. And then the one at the bottom, you can't read all of, unfortunately, is a joint NASA European Space Agency mission. And you've heard about Perseverance, which is the latest rover that we landed there, that's been driving around in the Jezero crater. And as it goes, from time to time, they drill and fill sample cans like that one you see there. It looks like a lightsaber or something lying on the surface of Mars. They've got 38 of them that they took. They've filled 22 of them now, at various locations. And they're dropping about 10 of them at a particular area called the depot, so that when the sample return mission goes up there, if it's not able to get to Perseverance and get theirs directly, it's going to go to the depot and just pick up those 10. But at any rate, by, you can't see the dates, it says out to 2032, actually. And so by 9 years from now, we will have launched a mission that will land on the surface, pick up the capsules. It won't have enough propellant to get off the surface and back to Earth, but it can get into Mars orbit, where it will rendezvous with the European Space Agency spacecraft, give that the capsules, and that will bring it home. So it's quite a coordinated mission, and it's been well funded and in development and well along, so we'll see. All right, so a favorite topic here, we've talked about a couple times, asteroids and the different kinds of asteroids. We're all familiar looking down in the solar system there with all those green ones in the main belt, which was what we used to think was the only place for asteroids in general science. And there are now, by latest count, over 1.3 million of these that have been identified, tracked, numbered, and in many cases named, and are recaptured from, looked at from time to time to make sure that we understand the orbital elements. And they're all very well behaved out there still between Mars and Jupiter. And then the red ones, let me look at the blue ones first. I think, hopefully I can see it from here, hopefully you can. You see the two Trojan clouds in the Jupiter orbit there, ahead of Jupiter and behind Jupiter. Jupiter's about the 130 position there in the outer ring. And so that's where Lucy is headed right now to do its flybys, I think beginning about 2029. But it's well on its way, and you'll hear it in the news soon because it's passing through the asteroid belt, and they're going to try the instruments out there. At any rate, the ones that we care most about, though, are those red ones that are inside Mars orbit, in many cases crossing Earth's orbit, the near Earth asteroids, many of which are in the category of PHAs, potentially hazardous asteroids, large and on a path that's going to bring them very close to Earth. So that's the state of what we know at this point. And from that, before 2010, I think maybe 2008 or 9, was the date at which they decided to choose what was going to be the target for this mission. And so at that time, the count was way less than 1 million, but they had to decide from that 500,000 plus where they wanted to go. And so the first decision they made was, we don't need to go out to the main belt. Let's just find one that we like that's not just near Earth, but it's in a favorable inclination, so we can get the most bang for our buck with our booster. And so that narrowed it down to 192 candidates. Of those, they didn't want to choose one that was too small because they rotate rapidly. And trusting the ability to touch down, sample, and lift off without hitting something is harder to do in those conditions. So they wanted to go for a larger one, 26 candidates. And then finally of those, they looked at the data that they had from spectroscopy about the content, the composition. They wanted a carbonaceous one, and the one they really liked best was Bennu. And Bennu, probably not coincidentally, also happens to be a potentially hazardous asteroid that's at the top of the list known as the Palermo Impact Hazard Scale. And so this is the list of those potentially hazardous ones that have at some date in the future a calculated orbit that's going to come extremely close to Earth. And they're of such a size that it'll be very dangerous. Now, in the future, in this case, means there's a better than a 1 in 2,000 chance that about 150 to 250 years from now, it's going to hit us. I mean, that's the way orbital mechanics works. Once you've got the orbital elements, you can run it as long as you like. Now, there are perturbations, and you're going to hear about one of those in a minute, the Yarkovsky effect. But for the most part, you know, there's no friction, there's no weather, there's no nothing except good old, mostly Newtonian physics guiding what's going on out there. Very reliable. So let's look at Bennu now. And to start, let's look at the two asteroids visited by the Japanese. On the left, and these are pretty much to scale, is that sea otter looking one that was relatively smooth and visited over a dozen years ago by what they called Hayabusa. And they thought they were seeing what it is we're going to find in all of these small asteroids with the smooth surfaces here and there. And so they didn't think it was going to be that difficult to sample the larger ones, but it turns out that it was quite different when they went with Hayabusa 2 some half a dozen years later and went out to an asteroid that's a kilometer in diameter and has got much more in the way of dangerous boulders and mid-sized rocks all over the surface. So they had to be really careful sampling Ryukyu there. And then finally, we have the one that OSIRIS-Rex went and visited. Very similar shape, not surprising. You see as the material clumps together and becomes an ever bigger, what do we call, a rubble pile these days. Gravity causes the rotating equator, if you will, to sort of collect more, just like the Earth is somewhat oblate, fat on the equator. But these didn't get a chance to become completely round, but it's no coincidence that you see that wider equator there. And so we got out to OSIRIS-Rex to find that it was very, very crowded. As a matter of fact, here's a close-up of a typical part of the surface. Now, this is a ½ kilometer wide, so think about that. 250 meters in diameter. And so 125 meter radius, that's really not very big. Picture, 400 feet away, that's a hemisphere, if you will. And so you have to find smooth areas to go down on this rotating asteroid and linger and then touch the surface, sample, and then come back up. So it took them quite a while and a lot of reconnaissance, as you'll see. So now let's look at the spacecraft for a
John,
minute. Yeah.
could you comment more a little bit about that rubble pile?
It's the it's going to become the go-to description of everything smaller than about 1 kilometer these days.
So it doesn't mean it's a collection of little rocks. It is a cohesive.
It is
unit.
a collection of little rocks,
Little
size rocks and big rocks and fine material. And it all came together probably way back at the beginning of the solar system in the first half billion years or so, as all the material in the various orbits out from the sun found itself And if it didn't get big enough, like it didn't in the asteroid belt, but stayed many pieces, those pieces were once much smaller pieces in most cases. And some of the ones that initially were quite big got hit by something else quite big and maybe became half a dozen smaller or medium-sized pieces. So that went on for quite a while. But what it left us with is loosely coupled, if you will, bodies of various sizes and shapes. Now, you're going to hear more about that. I don't want to get ahead of the story here, but we'll talk about that when you actually see, when we see what happened at the surface when they sampled. But I do want to talk about the spacecraft here, which in the upper left there is the way it is with everything stowed, that green box there. It's about 10 foot square, weighs about half the mass of a family sedan, so you get a feel for it. And staring at you in the middle there is the sample return canister, that round thing. And on the left is the sample arm that's stowed. And on the top and bottom are the solar panels that are stowed. And then the other two visions or images there show you the deployed solar panels. And on the right side, you see the sampling arm deployed just as it is down to the surface. It's about 10 feet long. So, as I said, it isn't just for sample return. There's a whole lot more going on as we were there for a very long period of time to study this asteroid up close. I mean, remember, it's only a quarter of a kilometer, I'm sorry, half a kilometer in diameter. And so, among other things that OSIRIS-Rex did, it set the record for the closest approach, or the rendezvous with the smallest body and the closest orbit around a body. It had literally thousands of orbits over a couple year period at an altitude of quarter of a mile. Now, if you think about a LEO spacecraft, like all those Starlinks that you were just seeing, and you think about, well, they're way up there, 200, 300 miles, except our radius is 4,000. So they're like, if they're 400 miles, then they're 10% of our radius. Well, 10% of the radius of a half kilometer body is 25 meters. So you didn't get down that close where you could almost reach up and touch the thing going around. But they did go down and spend thousands of orbits within a half kilometer or so of the surface. And they got a lot of data with the cameras and imagers, as it shows you, as well as getting a lot of compositional information from a whole set of spectrometers. And then finally, they had an altimeter on board. The altimeter, much like you may recall, we talked about climate change. The Jason spacecraft is the same thing, a laser altimeter that we use to have a perfect understanding of sea level height. As we go around and around and the Earth rotates underneath it. Well, that same thing is done with a laser altimeter on OSIRIS-Rex so that they can have a perfect understanding of the topography and literally all the sizes and shapes of those rocks and boulders you see. That's not a really huge body to map, and so they've got it mapped in three dimensions very well. But it turned out that it wasn't as useful for actually picking a landing site because it's just too busy a body. And so they had to use more reconnaissance imagery to pick that out. All right, so I ended up with 3D maps of the entire surface and lots of composition information from the science instruments. And so first, let's look at what happens with this wonderful little sampling arm and that little piece at the bottom of it that's going to gather the sample. And so there it is. And that's obviously done before the mission in a 0G simulation where that little sampling head there expels compressed nitrogen in order to kick all of the material up so that when it lifts up, as you'll see it do in a second there, the material comes up and gets into the sample head, and it goes inside and is collected around the inside of that outer ring. Now, to understand the size of that, most of you have gone to Pep Boys or someplace and bought an air filter at one time. This is not very different than just having an air filter. If you remember doing that, you take it out of the box, it's about a foot wide. It's about what that is here. Okay, so that gives you a feel for what it is. So that was what it was expecting.
This zero G
Well,
test happening.
And that's,
I imagine they did it on the vomit comet.
and it doesn't look like, it looks like low G, not zero, because it does look like things are falling back.
Well, their microgravity is a funny thing.
Yeah,
It's gravity, but it's very, very small.
right.
Anyway.
So you think it was done on
I'm
the,
telling you what the NASA script.
right?
All right, so now let's just kind of look at the macro view of the whole mission. So on the right there, you see launch in 2016. And so it went around the Earth twice before it actually got to Bennu, used the Earth gravity to put it into the trajectory that they wanted. And so the arrival took place there at Bennu, which is that red curve in 2018. And so they spent, like I said, a long time doing science and doing examination of the entire reconnaissance of the entire surface. And eventually they picked a place, and eventually then, as you see, 2020 is the date on that. So it's well over a year later, they had chosen the place that they did want to sample. And over the months then of 2020, they did two different kinds of rehearsals where they actually flew by this place very up close. The match point rehearsal was interesting because that was the one where they executed a maneuver that didn't just go down, but they calculated what was needed to match the rotational velocity of Bennu so that they would effectively come down straight down on it as they came down slowly, and they rehearsed that. And then finally they did their collection in October of 2020. What's that, exactly 3 years ago. And so at the time they did it, this was the configuration. It was twice the distance, the sun-Earth distance away from us, a little more than that. So the one-way light time was 18 minutes, which means obviously that they couldn't do real-time commands. It was an autonomous set of activities, and everything worked perfectly. So here's another simulation where that little dot is bending. That was the arrival. And after arrival, it went through these dances, trajectories, to get every possible lighting condition and every possible altitude to really get a good look at all the different possible places and understand the surface. And finally, they went into these two different orbits where they spent thousands of orbits at a couple different very small ranges. Finally, they had selected the spot and they did the rehearsal here, where they literally came down and did everything but touch the arm to the surface. And then in October, they did the real thing. They did their sample. And now they didn't come back for almost 6 months. They did a lot more reconnaissance. They went back and took imagery of what happened when they did the sample. You'll get a chance to see that in just a minute.
And it was like a touch and go like that.
Yeah, as a matter of fact, it's called tag sam, touch and go sampling. And
just the arm touched or the whole thing?
you're gonna get a chance to see it. That'll answer the question. What I want to do now is not really take a diversion, but stay with what happened during the mission, which is now there was 2.3 years before it was going to get back, which it did. It wasn't quite a week ago. It was actually about 3 weeks ago. And at any rate, in the meantime, they did a bunch of good science. And so one of the first things was something they'd never seen before. And they saw it happen over and over again while they were orbiting. And that was basically, in the technical term the scientists used, was particles jumping off the surface. So that's how they described it. They didn't know why, but it turned out every 3 to 4 weeks, they'd see some kind of an event like this, where grains and rocks up to about 4 inches in diameter would be kicked off of the surface. And so it happened in January, it happened in February, like I say, it happened just about every month. If you watch the next one here in September, then I'll just point out up there at the top.
And then
you
show
see-
you multiple
so
happening at,
It,
Okay.
yeah, good observation. It happened in different places on the body, which makes you think that maybe it had to do with something that hit the body or something that caused the body to shake. At any rate, what you see here is interesting because depending on the mass and of course the impulse, the force that it got when it was kicked off, most of them were in ballistic trajectories and didn't make it into orbit. They just came back out on the surface, maybe 50 meters, 100 meters away. But there was sufficient energy to kick a lot of them past escape velocity. And now think about escape velocity for a body that's only this big. And so if you read like I did, I think one of our Arthur C. Clarke's books, 2020, did he write, or 2050, something like that. At any rate, the last one I read, they visited a small asteroid and they had to be exceedingly careful as they explored not to step too hard and kick themselves off into an escape orbit. Because basically it doesn't take much. When you have only 8 microgravities, and that compares to, for example, the International Space Station is 5. So it's effectively 0 gravity. There's enough to hold it together, but it doesn't take much to kick yourself off, to give yourself escape velocity. So one of the things
I'll
they
play basketball on the asteroid.
wait till you see what will happen to the basketball.
Yeah.
This,
Yes, sir.
the spacecraft is orbiting the asteroid.
Mhm.
How does it stay in orbit?
That's
my question too.
I mean, the way gravity works in the crudest way is 2 objects attract each other and go into orbit around each other, as long as there isn't something bigger nearby that pulls them away. So it's all by itself. And we were able to bring its velocity into sync to rendezvous. You know, let it be captured by Bennu's gravity field. Yeah. They didn't, the delta V's required to do all those dances and changes of orbit were extremely small, a centimeter a second kind of thing. I mean, much different than what we've seen the Apollo spacecraft, for example, or somebody else do to boost their orbit, change their orbit. So just little tiny delta V's is all that's required. And yes, they were able to go into orbit and stay in orbit because Newton and Kepler, and they did a good job of explaining it all. It works. At any rate, so what's going on here? Because they hadn't seen this before. And so they were able to understand that they were voids under the surface. They were able to do a better job of estimating the density, which has a lot to do with maintaining an orbit and being able to accurately, very precisely understand the gravity field. But from what I read, and I admit I read it in a Wikipedia article, it is, the theory is that, let's see, first of all, there's a lot of water on asteroids. And we've pretty much proven now that asteroids coming to Earth was very responsible for bringing most of the water to Earth, and still do when they come. But at any rate, it's something like 1 to 7% water, depending on whose particular approach to the calculation you believe, but it's a significant amount of water. And so at times there are parts of the body that will just have water-based events and come apart, explode, however you want to do it, and cause material to come off the surface. Just like a comet does when it gets in closer to the Earth, inside the ice line, heats up And literally, the pockets of water become vapor and explode the material around them. So some version of that is happening here. We believe. Anyway,
These are pockets of liquid water?
no,
Okay.
water in the, there's a name for it, and I'm not sure I can remember. It's water on the surface.
All right.
I mean, you could picture that as taking a pebble and dipping it in water and it's wet. I don't think that's literally what it is, but it's not in the rock. It's on the surface of the rock, surface water. There's a name for it. but I forgot. What's that?
Absorb.
Yeah, exactly. Exactly, absorb. All right, so another thing that they were able to do with their science, if I can get to it here. Interesting. Okay, was use of spectrometry now to understand the composition. So at the left there, you're looking at the Nightingale crater, which was the one that they actually sampled. And the rings are just using a color coding to identify what kind of minerals and materials they found on the surface. There weren't any big surprises in terms of things having a history of water, lots of hydrated materials, organics, which we expected to find and did find. But the surprise on the right there was these pyroxene xenoliths. And if you think I know what I'm talking about, I have no idea what I'm talking about. But I'm just repeating what they've told me and what I've read. Those are materials that they identified that are for sure not from the original Bennu asteroid. They came to the surface from somewhere else. Don't know how they know that. They suggested that it could be from any other body in the asteroid system. And of course, Vesta's in the main belt. So that was just an example. But their point was that material we understand now leaves asteroids, as we now have witnessed happen over and over again, and doesn't just stay with the asteroid or come back down on it, but reaches escape velocity and is in the vicinity and lands on another asteroid, perhaps. And so there's a lot of mix of materials. There was so much of this, and they calculated so much of it, that they being some NASA research people, they went to the southern hemisphere, I think it was last year, when it passed close to the Earth, and they did their best to see if they could see material, sort of like a meteor storm, as it passed near to Earth, and all these particles that we now know are sort of traveling along with it or off of it, might actually give them something that they could see in the way of a little meteor storm. They didn't see one, but it just kind of emphasizes the fact that space is a lot less empty in some ways than we think it is. There's a lot of stuff traveling from place to place. All right, so the security side, the planetary defense side, has to do with the fact that Bennu, in that white orbit, as it is coming to a close approach, in the lower left is the calendar. In September, a little over 100 years from now, it's going to have a very close approach, at which point we will be able to have a really precise calculation of whether or not, for one of the predicted close approaches, about 40 to 140 years after that, actually might be one that's going to impact us. So not anything to worry about today, but it would be nice if 100 years from now, if it turns out when it makes its close approach, and they figure out that in 2183, it's going to hit us, that we've got something in our arsenal to do something about it with. And a half-kilometer asteroid is one that will actually do a lot of damage. It's much, much bigger than the Arizona meteor crater and what was the one in Russia a few years ago. But anyway, yeah. So, but the point of this is to say that we are also able to understand effects on the orbits from perturbations, and in this case, study the effect of something called the Yarkovsky effect. And most simply put, it's for every small rotating body that is obviously seeing the sunlight all the time. It's the effect that's caused by the thermal radiation coming into one part of the body, rotating and being emitted from a different part of the body. And that causes a net force, not just a change in the rotation. And that force has an effect, as you can see here. So they were able to calculate that the semi-major axis, the distance from the sun, over a 12-year period changes by 185 kilometers. That's quite a distance. Until you realize that it's like a diameter of the orbit is like 185 million miles. So over the whole, scheme of the orbit, if you will, 185 kilometer change isn't that much, but it's something. And understanding it may be very useful to us in the future so that we know when we're predicting some asteroid to be on a collision path, what the Yarkovsky effect might account for in the way of changing that orbit, because we always expect to be able to predict these at least a couple decades or more out. And so there are going to be quite a number of orbits over which you can have a change due to just this effect. So they studied that well. And then finally, this appeared about a month ago in the local news. And I don't remember now who the researchers were. They were publishing in Icarus, the planetary science journal. And this was a very interesting finding about what we think we understand about at least this asteroid in the way of layering, which we didn't expect. And so they were able to, over a long period, remember this 2+ years kept the scientists kept very busy with all the different imagery they had. So they kept studying the surface, and they discovered a difference between small craters less than 25 meters, like the Nightingale crater in the upper image there, and the larger craters, where the smaller craters had smooth sides to them, ovals. And the larger ones, like the couple that are pointed at there in the lower right, pretty much had a side to them that looked just like the rest of Bennu. Medium rocks, some big rocks, but nothing that looked very smooth. And so they came up with a finding, they claim, that it's not just a homogeneous rubble pile, but that for some reason, below the surface layer, for as much as, say, 10 to 15 feet, you have a compacted layer of very small material. I'm just saying out loud the words that you're reading here. We're going to learn something now that we've brought back some material from exactly what we're talking about, that layer just below the surface there inside the Nightingale crater. So we'll see if we find something in the sample analysis now that refutes that. But it's kind of an interesting theory, kind of thing I like because it's got a good name. It's called the Brazilna theory. And so if you picture it, take a bowl and put a few cans of mixed nuts in it, and you shake it. Well, the big things don't go down. They all stay on the surface. And so over 4 billion years of small bodies that are not very much gravity, from time to time something hits them, or for whatever reason, like what causes the jumping particles there, they shake a bit. Little by little, the material on the surface is shaking down until apparently, at least the theory is, it's compacted itself into a layer below the surface, which would be quite interesting. And it allows me to point out that what we really are caring about as we visit and observe the surface of these, especially by going down and touching the surface, we're starting to understand what it will take to actually deflect one of these things. And to understand that, we need to know when we hit it, hey, we're not going to hit it like that. It turns out we're going to hit it like hitting a bowl of popcorn or hitting a ball pit, that your kids are jumping around in. Most of the stuff slips right by and it doesn't resist you much at all on the surface. If it turns out there's quite a large compacted layer of smaller material, that will make a lot of difference in the momentum transfer, which is what DART looked at a year ago and what Bennu has now looked at. And as you'll see, we have another mission going to one that will give us some more information. So we're always trying to learn about what these targets are actually going to be like if we try to go out there and deflect one of them. So we arrived in 18, they did the site surveys, selected the site. completed the rehearsals. Sampling day arrived, and here's what happened. These are live pictures as it went down to the surface. There's a camera on the left called the SAM cam, looking down on the foot from above. On the right, there's one that's an oblique view of, you can see it in the green box there in the center. It's looking off to the side, so that you'll see the shadow of the arm come in just before it touches, and you'll get a chance to see what happened when that foot touched the surface. So here comes the shadow. It's just about to hit. And so it was going to touch, maybe push a little bit and then blow up, except that there was just a complete explosion of material. And you'll see in a minute what we, after the revisit and looking at the site that was sampled, have learned about what actually happened. But the retro rockets fire and take it back off the surface. There was in that arm that you saw going down to the surface, and you saw how it compressed before, there was a switch in that which never was compressed the whole time. It just kept going and going. It didn't actually stop and start to lift up again until the retro rockets fired and started to push it back.
So it didn't bounce.
It didn't bounce.
Yeah.
It didn't find a crust. There's nothing like a crust. Yeah, so
It
now
really was like jumping into a ball pit.
yeah. So now we'll take a look here at, hopefully I can jump to the middle of this because it's pretty long. It's a really good video that Goddard did. Goddard's the prime contractor on this, incidentally. And what I need to do is get out to about here. Do we have, you know what? Okay, we've got.
As a result, loose material in the lunar subsurface is packed together more tightly, making the movement. It would sink into the ground.
Is that the
by
one,
about
Benda?
half a centimeter. Would yield a dramatic.
Okay. So now you're gonna see a, computer imagery of, based on the data of what actually happened.
Benda consistently defied scientists' expectations, as each new finding reveals another facet of this small but surprising world. Using data from OSIRIS-Rex, we now have the ability to look back and accurately recreate 30 seconds on asteroid Benda. On October 20, 2020, OSIRIS-Rex made its final descent to a sample site called Nightingale. With its TAGSAM arm outstretched, it approached the surface at 10 centimeters per second, the walking pace of an insect. 1 second after contact, it released a canister of pressurized nitrogen, detonating an explosion of particles and driving material into the TAGSAM head for sample collection. 6 seconds after contact, while it was still sinking into Benda, OSIRIS-Rex fired its thrusters to begin the back-away maneuver. The engine burn lasted for 24 seconds, continuously pushing against the spacecraft and rapidly slowing its descent. Flying debris from the thrusters and the gas release pelted the science instruments, clogging them with dust. 9 seconds after contact, when OSIRIS-Rex had sunk nearly half a meter to Benda, it reversed course and began to rise. At 16 seconds, the TAGSAM head re-emerged from the subsurface as the spacecraft continued to accelerate. 30 seconds after contact, OSIRIS-Rex shut off its thrusters and drifted away with its sample of Benda. Almost 6 months later, on April 7, 2021, the spacecraft returned for one last flyover to observe its footprint. At the point of impact was a new crater, averaging 8 meters across and reaching 68 centimeters in depth. Thruster marks overlapped with this tag crater in an X pattern, increasing its volume by as much as 40%. A ridge of ejected material that had been kicked up during sample collection and then fallen back to the surface circled the crater like a campfire ring. With a puff of gas and an engine burn, OSIRIS-Rex had displaced 12 cubic meters of granular material, 6 tons of loose rock that may have been packed together as lightly as a bowl of popcorn. After a final departure maneuver in May 2021, OSIRIS-Rex began a 2-year journey back to Earth. Stowed on board were about 250 grams of asteroid Benda, a bounty of scientific treasure destined.
Okay,
So, you know, like I said, the most important thing to me is that bowl of popcorn. And the fact that it was, you know, it was theorized that maybe it was gonna go 2 centimeters down, something like that. And the arm would compress and the nitrogen gas would be released, the material would come up. It went 10 times that far. It went about, I think he said 0.5 meter, about 20 inches. And wasn't finding any particular resistance. The way they've described it in the various scientific articles is it's more like a fluid than a surface layer. So that matters a lot in terms of kinetic impact of potentially hazardous bodies. It doesn't mean, well, I'm not going to say what it means. There's lots and lots of research being done right now to try to understand this, because we want to know whether or not we can actually have a kinetic impact approach for asteroids in this particular class from 0.5 kilometer to 1 kilometer. So let me go on here.
Maybe you'll touch on this, but with things like that, I mean, if they're that easy to plunge into, could we not just, I don't mean, this sounds maybe like too much deep, but basically fly right in the middle of it and detonate and disperse it?
Well, then we get hit with a shotgun.
But maybe, but if it depends on how much it disperses, maybe we'd only get hit by 2% of it, you know?
Excuse me, Jeff, I always have trouble getting to the next slide. For some reason, I usually have to escape.
Yeah, let's
and
see
come
what we
back
can
in.
do.
Where's the escape button here? Try that.
Let's see what we can do here, John. Yeah. Oh, let's.
Okay, now I want to go forward 1 slide. There we go.
We back in business?
We're good. We're good. All right. So here again, this was a live image just after the touchdown, looking at the sample head. And it's not actually a movie, it's 3 images that you're seeing looped. So you get the idea. You'll see particles moving in towards the inside of the foot there. And so they'll go inside and to the inside of that white ring there. The object, I'll just point to it as I can here, instead of describing it. This is a rock. And the rock is stuck holding the mylar flap open. And so if you paid attention, as some of us did back then when the actual event took place, they were very concerned for a day or so as to whether or not they'd been able to close the flaps so that they were holding the material inside. And since they were afraid the flap was open, the technique they were going to use, which was to extend the arm and spin the spacecraft in order to get a precise calculation of exactly how much material had been added. They didn't do that because they were afraid they'd lose some. So it's still just an estimate we have based on re-entry calculations and so on. They've estimated it to be about 1/4 kilogram, 250 grams. So here's another real picture showing the head being placed down into the sample return capsule. And you see that little locking device on the right. And when it hits, there are particles flying off and scientists screaming, "Don't let them get away." That's the kind of thing that happened. And you'll see now that the material's been returned. What's happened since we opened it up to see what was inside, but.
And by estimating estimate at that point in time.
At that point. in
Yeah.
time. Yes. So now here is what happened then. There's Earth's trajectory. Here we get, we met Bennu there. 4 hours before re-entry, it just drops the capsule from the spacecraft. And then the capsule by itself re-enters, heats up, the drogue and the main chutes come out, and it drops down here, just as the previous Lockheed Martin capsule did, into the Utah desert there, as you'll see. That was what was going to happen. Last Sunday there is an error because I forgot to change the slide since the last time I gave the talk. This is the 5th time I've given this talk now. Here's a side view of that same trajectory. So you see OSIRIS-Rex up there after it's dropped off the SRC, and you're going to see what happens to that in a minute. But after it comes through the atmospheric interface there 4 hours later, heats up, gets to peak deceleration and heating at about 60 kilometers up. And then it landed as expected within the computer generated projections of that error ellipse in blue. And it did land within that. But the best news was it landed within the Utah Test and Training Range, which is an Air Force facility that's that abuts the Dugway Proving Ground of the Army. And it turns out what it actually touched down was just a few feet inside the Air Force Park as opposed to the Army, which of course they were going to take advantage of the Air Force when they got to the press that day. But at any rate, it did successfully land. And so let's talk about what happened to the spacecraft. So the spacecraft, it turns out, has still got propellant and power working just fine. And so there had been another mission that had been proposed. And so literally after the return canister had been stowed on its way back, they went to the higher ups and got funding for a second OSIRIS mission, which is going on right now. And APEX is for Apophis Explorer. Apophis, like Bennu, is a potentially hazardous asteroid. As a matter of fact, some of you that may have been paying attention for decades, I do remember hearing about it, but about 20 years ago, literally, it was at the top of the hazardous list. And it was actually forecast that Apophis was going to, with like a 4% chance, which is a big chance, impact us in the late 20s, this decade. Turns out that by the time they did enough looks again at the orbital elements, they were able to conclude that it was going to miss us slightly. But it's still on a path to us, and that's where OSIRIS-Rex is headed right now. So on that date, in 2029, it's going to pass just kind of at the same altitude as the communication satellites are. It will miss us, but it's going to be close enough that it's going to be naked eye visible, but not from America. Unfortunately, Europe and parts of Asia, I think, are going to get a look at this. So you may want to put that in your travel plans. I don't know. At any rate, that happens on the 13th. 5 days before then, OSIRIS will be near enough that it'll start to use its instruments to do reconnaissance. It'll rendezvous, just like it did at Bennu. It'll spend 18 months orbiting, and it'll pick a spot, go down, and it won't sample because there's no sample arm anymore. But it will go down to the surface, fire the retro rockets, disturb the surface again. And for an asteroid that's about 2/3 the size of Bennu, we're going to get another chance to look at what that surface acts like when we go down and, you know, transfer some energy there. So here, it'll start over in a second. The blue is Earth's orbit. Apophis is that magenta color. So here, if you look in the upper left there, you see the date 2028. So in April of 2029, right there is the close approach. And the change in orbit is what we expect because of Earth's gravitational tug on this as it passes. And we expect that it's going to substantially change the orbit of Bennu by about 20%. So that's what happens with, you know, gravitational assist. All right, so the event did take place September 24th. Did any of you watch it?
Yeah.
Yeah,
7 minutes earlier?
they've gotten pretty good at PR. Yeah, it was a little early, yeah. At any rate, there it is, sitting on the surface with the parachute nearby. And here's a little close-up of it, all charged for re-entry. And to give you a feeling for the size, they're the initial guys from NASA that got out there to do some study and to look at some things in the area and put some flags down to study this and that. At any rate, they hooked it up within about 2 hours to a nice sling, hung it from a helicopter, and took it to a clean facility at Dugway Proving Ground. And so the first day that it was back, they actually had the top off within about 3 or 4 hours. and were looking at things. They didn't go into where the material was. They were just checking out, I don't know exactly what they were doing, but they were given the opportunity in their clean room to do something. But that was in advance
What's
of,
the yellow thing? It looks like a daisy.
The decal on the side, the sign on the side.
That didn't get charred?
I'm sorry, what did
Like the sticker that they put in when they were covered.
This yellow, orangey,
yeah, I can't tell. I think that's
maybe
there.
put that on after it landed?
I don't know. I'm trying to see you. I don't know.
Yeah.
Good question. You know, you could probably go out on the internet and ask it,
On the
find a whole
sign on top.
discussion group for it.
Right.
So here was the real destination. That was NASA's facility at Houston. They've done moon rocks and stuff for 50 years, but they built a new clean facility for this. And that staring at you there is aptly named a glove box, okay? It's a hermetically sealed box where they're gonna put the samples, and you can picture what happens. You put your hand into those things, and here we have guys that have there are two on each side, space for two people on each side. Here they are lifting the lid off of it, and here they are tipping it back and setting it, you know, in a place where they can set it out of the way. But what happened at this point was they saw so much material, and they hadn't yet gotten inside the collection canister there, that they put this on their blog. They said the sample runneth over, and so they stopped. And they stopped and haven't, as far as I know, I checked again yesterday, they still haven't opened up the actual sample canister because they got so much stuff. And on the 11th of October, which was what, a week ago tomorrow, is that right? It's just 7 days.
Something like that.
Yeah, okay, a week ago tomorrow, I watched their press conference, which was again on NASA TV at 11 in the morning. And it was just, they really did a good job of this. They had the actual researchers from Goddard and Johnson there, and they talked about what they'd found so far after about a week and a half of looking. And this is the material that they found. They didn't expect there to be material because they thought it would all go inside. The flap would hold it in there, and they just take the top off and everything would be clean like they built it. But they found lots and lots of material. Now, it wasn't big. Dust and grain-sized particles. They're not very big particles, but there was enough there, and they already had their techniques down pat. So they've done a lot of science on it already. As you see, they found, and this is now a Johns Hopkins team, found the highest abundance of carbon, and they've looked at 250 meteorites in the past, and this particular one. Now, remember, the target was a carbonaceous meteorite. So, as the guy said, he said, we could not have picked better. This is exactly what we wanted. So they're getting a lot of good material. You see the tag SAM there in the center, the air filter there. And so they haven't yet opened that. They've done electron microscopy on the stuff that they have. The scale is very interesting there. I mean, the scale is on the order of microns, you know, thousands of millimeters. So we're looking at really tiny things here, but I won't take the time to read the kinds of materials. They don't mean much to me, but if you want and you know about this sort of mineralogy, I'd be happy to share it with you. But just suffice it to say, with just the stuff they found so far, they're very excited about it in terms of understanding things that have to do with the age of the solar system, the origin of this particular material. I don't know how they do it, but it's remarkable. So there has been a big plan, which they're going to execute as soon as they get all the material out. And that is to take 25% of the material and distribute it to a number of places that have proposed their projects and their instruments and their personnel for going back years now and been selected. And you see 38 places on 4 continents are going to get some of that first 25% of material. The 3 ones in red there are 2 NASA centers and the University of Arizona. They're going to be the main research sites, but there are a whole bunch of others that are going to get a chance to do these kinds of things. Many different instruments, lots of mass spec approaches, different approaches with mass specs and lots of spectrometry. X-ray, spectrometry, of course, and so on. And down in the upper right there, kind of a good example, the lady in the blue sweater there is working with an Apollo 16 sample that's just come out of storage that was brought back way before she was born in a facility that didn't exist initially, but on instruments with techniques that were developed way after the Apollo missions. So that's the kind of thing that happens is a generation or two later, you still want to be able to have material left so you can use the latest and greatest to study these things. So they're going to save 75% of it for the future, just like that. And there are a number of hypotheses that they're going to be addressing. Some of them have to do with comparing what they brought back with what they think they understand from all the remote sensing science that they did. Naturally, some of them have to do with what we always want to look for, which is life or something that will support life. And so there are a bunch of hypotheses that they're going to be looking at there. The largest share of things that they're studying have to do with origins, the history of the solar system, where the parent body, what the parent body was like, what relationship there is between what we have and the pre-solar material, what was in the cloud even before the sun lit up. I don't know how they're able to analyze this, but they've got some really interesting things that they're going to be looking for. And then finally, what's changed since it was collected, given that there's been a re-entry and lots of vibration. They've lost most of the volatiles probably. It's not a hermetically sealed instrument, unlike the Japanese. The Japanese made the decision when they went to Ryugu to collect very little material, but keep it all sealed up in a partial vacuum as it came back. And therefore they got some volatiles when it came back. In this case, they don't expect to get a whole lot of that, I don't think. And there's a big trade-off between the weight to have, control over holding a vacuum and how much material you're going to bring. So we chose to get more material and not protect it in that way. So it says the first results are expected within days, and the total mass will be part of that. But the fact is, the first results, not sure what's going on here. There we go. Were already talked about, and they weren't about the total mass because they don't really know the total mass until they open it up. So keep yourself on the lookout for what's going to come next. I'm doing that. Just go out to NASA OSIRIS-Rex, and someday before long, you'll probably see a press conference or some kind of announcements. So that's it. I appreciate your letting me go on and on here. Right.
Thank you, John. Questions?
Yeah.
Bill?
Go back to the hermetically sealed thing. Does that mean that the atmosphere and things that burned off while this was re-entering would have potentially contaminated the samples?
I guess I'd ask some of the people that are working on that fourth area, what exactly they think might happen during re-entry and the vibrations, but I don't know.
You're saying like bits of the return capsule might have.
Well, and our own atmosphere.
Right.
Dust and bacteria or whatever's flying around.
I assume that it's sealed against, all particulate matter from the atmosphere getting in.
Well, if it's not sealed to prevent volatiles getting out, that's also not sealed to prevent volatiles from coming in.
You're asking good questions. I don't know.
At least it sounds like that.
I don't know the answer. I mean, maybe they're going to go, oh, why didn't we think of that?
No, I got it. There's got to be something.
I assume that they'll have a good answer, but I don't know what.
One other question,
Yeah.
With the loss of mass from Bennu and presumably all kinds of other asteroids, doesn't that mean that the calculations have to be, adjusted based on some estimate of loss of mass from asteroids in terms of their trajectory over long periods?
Are you asking, do asteroids for a variety of reasons have enough internal or external events like impacts that it will remove material to where they have a different mass and therefore a different orbit?
Right, it's not necessarily an impact, it may be, like you said,
It may be
result of
something
solar
internal.
radiation,
Yeah,
but
maybe
also
something.
if they're vibrating and as more as a liquid than as a solid, object.
Yeah, that's certainly not the picture.
Occasionally,
Yeah, that's not the picture I have. I don't picture them as a small, heavy, massive core with a bunch of popcorn around it. I don't know what it is.
Okay.
I know that they use that as an analog for what the surface is compared to being something like the pie crust or something like that. It doesn't resist even that much, but that's just the surface. I have no idea 5 meters down what it's going to be. That was half a meter.
Yeah, you mentioned a 4-inch size piece
Yeah.
actually reaching escape velocity.
Mhm.
Okay,
Well, I didn't say that. I said, what you see is anything from tiny grains up to 4 inches.
okay.
It could be that most of the ballistic ones were, anything over an inch. Might have been massive enough to come back down on the surface. In other words, I don't have any idea, and I'm sure somebody's trying to calculate it, what it says about what energy there was in those jumping events, if you will.
Mhm.
So in the glove bag, I assume they have to have an inert atmosphere?
Yeah, they have a nitrogen purge on all
Okay.
the time. Yes, sir.
So we got the Brazil nut theory.
Mhm.
So is there a reason that this one's different than that one? They're younger, they're in a more crowded place, or why is one smooth like where Hayabusa went and one's not smooth?
Well, let's see. A rocky, this is a very layman's view, reading a few words that they've given. The sea otter looking one that was only half a kilometer long
Right.
and much narrower and quite smooth is a rocky asteroid.
Okay.
Okay, there's the answer, I think. The others are carbonaceous and they're rubble piles of a variety of sizes of material, but none of them they aren't like, the little one, I'm trying to remember his name. At any rate, the little one is almost like one big rock. Okay. And as opposed to the others, and that was by design, that they wanted to see one of those and one of the others.
Okay.
And as far as DART goes, which hit Dimorphos, was the name of that asteroid. And it was, if you remember, I had an image that showed it hovering over the Colosseum. So it was not a half mile or a half kilometer in diameter, something smaller than that. The images we've gotten before and after so far from Earth and from the little Lichia Cube satellite that accompanied it and flew behind it and took images indicate that it's a lot like what we've seen at Bennu. There was a whole lot, when it hit, NASA had given us an artist concept of that, an animation that showed it hitting and a little bit spewing, a little bit of dust coming out. It was completely different than that last September. A lot of material came out of that one. Like something bigger like Bennu showed at the surface there. Again, each of these is a one-off data point that's helping us to understand what these things are really about, because we need to understand them. Yeah, Rob.
So one suggestion, if we find one that's particularly dangerous, we can maybe discover some sort of interesting thing in its composition or kind of make up that there's something interesting in this composition, and then tell the Elon Musk of the world that they should go mine it. And maybe we can get like a competition to just take all the pieces away, and then there won't be enough. Let's go think it out.
What is it, we found that it's 73% unobtainium.
There we go.
It doesn't actually have to be that, it's telling.
Just tell
Oh, wait a minute, wow. The government wouldn't do that.
them. Are there any questions from the folks online?
See two in the chat, I don't know.
I think there might be something in that.
Yeah, well, if anyone, it's not convenient for us to get to the chat. If anyone has a question, online, please speak up. Or if anyone online knows what's in that chat, that's worth sharing. Okay. Yeah. Any final questions in person?
So where was this picture taken?
You do not.
Actually, I'll just, maybe a silly question, but I like to ask dumb questions. Why a land landing versus a water landing for the capsule?
That's a really dumb question.
Thank you.
Oh, you want an answer?
Yes.
Somebody did ask that, I don't remember the answer.
Okay.
If I had to guess, it's much easier to know where it is when it comes down. We've gotten better at doing reentry, but not that good.
Yeah.
So, you'd have quite, and also, okay, I do remember the answer now. The last thing they wanted was a bunch of people in their cabin cruisers and so on, and their skiffs and schooners or whatever you call them out there circling the impact area to see who could get to it first.
Yeah.
Just like, we didn't want a bunch of, does Utah have Yahoos? And there were a bunch of people in pickup trucks driving out to see who could get to it first. So that's why it comes into a military controlled reservation.
Yeah, got it.
Plus if it sank, Jack, there'd be one,
Yeah. Yeah.
They've done that when they used to drop film in and they had the US Navy go down
Hmm.
submarines to get to
Yeah.
film and stuff like that, crazy stuff.
Obviously the counter to that is, there's a bigger risk to it landing on land, because if you're off, but like I think where you said, we've got it down pretty good, that risk is low.
The comet return mission.
It didn't work. It went flat.
Yeah.
The sensor system.
Yeah, it went flat.
Any final questions?
Thanks very much.
Well, John, thanks again. Final couple of closing notes. Again, keep your eye on the groups.io. Diana Mesker, who normally brings our snacks, was not able to this week. So Dave Grosky was awesome in filling in for us. And final comment, just give me 30 more seconds here. Next month, our topic is we are going to be joined by Bob Sommerfeld from Astronomy to Go, and he's going to be giving us his atmospheric phenomenon talk that I think he's not given in about 12 years. And it is, for anyone that attended it, like I did, it was almost one of the first talks I heard. It is phenomenal. Bob is a personality not to be missed. So
This was the rainbow guy.
yes,
Yeah.
exactly. Yeah.
Yeah, that's
So,
good.
that is our next talk in November. So take care.
Thank you, Jeff.